In this video, let us continue to solve problems based on areas of combinations of plane figures. We've got a problem here which reads like this. The area of an equilateral triangle is 1732.05 centimeters square. About each angular point as center, a circle is described with radius equal to half the length of the side of the triangle. Find the area of the triangle not included in the circles and use pi as 3.14. Alright, this seems to be not a very straightforward question. It's a little what you need a diagram, right? So first of all, what it says is the area of an equilateral triangle is 1732.05 centimeters square. So let's have an equilateral triangle. So here we have almost an equilateral triangle, right? So the next step is about each angular point is center. So every angular point is center. A circle is described with radius equal to half the length of the side. So if you take, something like this, the circle is described with half the length of the side as the radius of the circle. So there are how many? The circle is described. So every point. So it's got three circles, right? So we've got one here, and then something like this. We've got another one here, and then we've got another one here. Something like this. This is not, of course, very precise, but it's a good illustration. Definitely not bad, I guess. So yeah, so what we have to do now, so this is the figure that we've got. The area of this triangle here is 1732.05 centimeters square. And we've got the circles. We need to find the area of the triangle not included in the circles. So you see there's a small gap here that I'm marking in the red. So that is the area of the triangle that is not getting included in the circle, right? So that is the one. Let me get the boundaries of the circle. Yeah, here it is. So if you see, that red spot is what we have to find. That is the area that we have to find. So it's pretty simple from here on. We just need to find the area of the triangle, which is already given, so it's fine. We need to find the areas of these sectors here, Let me shade those. You just need to find the areas of these and subtract them from the area of the triangle to find this space shaded in the red. Let's start solving the problem. So now the data is, we've got the area of the triangle as 1732.05 centimeters square. All right. So now let each side of this equilateral triangle be a centimeters. That's another thing. Let each side of the equilateral triangle be equal to a centimeters, right? So if the side of the triangle is a centimeters, then the radius of the circle is half the length of the side. So that should be a by 2, right? So the radius of the circle, or the radii of the circles, are a by 2 centimeters. It is an equilateral triangle, remember that. So now how do you find that? So the area of an equilateral triangle is given by root 3 by 4a square. So this is the area of an equilateral triangle, right? Let me mention here, area of an equilateral triangle is root 3 by 4a square, and that is equal to 1732.05 centimeters square. So all that we have to do is find a. So we've got the area of an equilateral triangle is root 3 by 4a square, which is equal to 1732.05 centimeters square. So what we'll do now is let's keep a square by 4 as it is and write 1732.05. The root 3 comes down, so divided by root 3 centimeters square. The reason we're keeping this like this, you'll note in a short while. So let's keep this like this. And you know that the radius of the circle is a by 2, right? Yeah. Or you can write this as a square by 4 can be written as a by 2 the whole square, right? It can be written as definitely as a by 2 the whole square. So now, what is this? This is a sector, right? These are the three sectors. So we just need to find the area of one sector multiplied by 3. So the next step is to find the area of each of the three sectors. So the area of the sector is given by what? A equals theta by 360 degrees times pi r square, right? This is the area of the sector. So we've got three such sectors here. So just multiply the whole thing by 3 So we get 3 times the theta of an equilateral triangle. This is the angle, right? So since it is an equilateral triangle, it should be 60 degrees each. So theta is given as 60 degrees divided by 360 degrees times pi is instructed, they're told to take it as 3.14 times the radius square, that is a by 2 the whole square. So now if you see, a by 2 whole square is given as this value. So straight away we can substitute this in the place of a by 2 the whole square. That is why I kept it this way. So now we've got 60 goes 6 times in 360 and 3 goes 2 times in 6, and we've got the left out is this one. So let us continue from there. A equals 3.14 times a by 2 the whole square is 1732.05 divided by root 3, and then we've got by 2 here. So that's all. Now solving this, we get 1570.05 centimeters square. So now what we found is we found the area of these 3 sectors, right? This is one, this is the second, this is the third. All are equal, of course. So the area of those 3 sectors comes to 1570.05. So all that we have to do is subtract these 3 areas of the sectors from the area of the triangle to get the area of the shaded portion in red. That's all we have to do. So the required area is given by required area equals area of triangle ABC minus area of 3 sectors here, right? So area of triangle ABC minus the area of 3 sectors, which is nothing but 1732.05 minus 1570.05 centimeters square, which equals 262 centimeters square. So the area of this small space here, which is shaded in red, is 162 centimeters square. Another very simple problem, all that we had to do was, subtract things. That's what has been happening, in the videos of problems based on areas of combinations of plane figures. All you have to do is find the area of different plane figures given and then subtract one or the other to get the area required. So that's all. In this problem, it was simple. We had to just find the area of the triangle here, and then which was already given, find the total area of these 3 sectors here, and then subtract those areas from the area of the triangle. So this ends this video, and I'll see you in the forthcoming videos with more problems.